Here we are doing more of this home lab stuff. We're going to be focusing on specific security solutions in the PKI space. I streamed for a good 6 hours yesterday about this and really dove into PKI, what it is. So I'm not going to go into what it is or any of that now. We're going to talk about specific solutions and implementations that I can implement at the hardware lab layer with the intent of modeling we'll say a case study, as I've said before, of like a small machine learning think tank that's private, that's publicly funded mostly, and doesn't have a lot of money. So that's the model I'm using for my decisions. And I, at the end of our evaluation yesterday, I got kind of in a bad mood at the end of yesterday when I was going through this, because the certification, the certificates, and by the way, we had a few people who were in here already who were like, what's a PKI certification? And they're thinking it's a software certification or security certification. It's not. PKI, just in a nutshell, is public key infrastructure, which is designed on, it's just a way to secure your infrastructure. It relates to having public key cryptography. But at the end of the day yesterday, a couple of realizations that are going to probably change how I organize my lab. I'm going to be doing these specific things today so that I can play, so that my certificates will be more valid and they'll be better, well-rounded and all of that. And some of that's going to involve like hostname changes, default domain, search domain changes, and the consideration of an HSM, which I have reached out to Entrust about. You cannot buy it from Amazon. This is not the kind of thing you can just go get. But I did want to point to something I did find offline just now. This is a quite an interesting device. I'm looking forward to potentially buying one. So we talked at length about the whole certificate authority thing, intermediate certificate authorities, and then actual certificates, and the private keys that secure those things, and how the best practice there is to keep your root CA offline. You would not want that on there. And yeah, it does. It folds up. It's kind of nice. It's cute. And when you need it, you plug it in through a USB and you get your certificates, or you do your signing and stuff like that. But once you have a root CA, you don't really need all the other stuff, right? Obviously, you can make these things without having a device like this, but I do kind of like the idea of having an electronic device store the things in addition to printing it out as a QR code or whatever. So, and this has all of this work has been triggered by my desire to not just half-ass the security of my Kubernetes cluster by assuming we're going to use all of the default keys. We did an extensive comparison of the default security of kubectl setup Kubernetes clusters yesterday to one where you manage it yourself. In fact, that's where I was actually drawing. Do I still have it here somewhere? Where is it? In my Excalibur draw. Yeah, so here is a properly set up PKI. I mean, and you might have several levels of intermediate CAs. You can have an intermediate CA that has another intermediate CA if you wanted to. So depending on how large your organization is, but this is the minimum. The minimum to do PKI properly, to do the security properly, is a three tier thing. Now I'm new to all of this. I mean, I've known about the concepts for some time, but I wasn't really able to really dig in. And yesterday we really dug in. We read every single field in X509 certificates and got an understanding of what they are and how to identify a self-signed CA as opposed to a credential down here at the bottom that's actually going to be used for something. And you may be asking, well, why are you so obsessed about all this stuff? Well, this stuff, this certificate stuff, is at the core of the emerging modern IT architecture for zero trust. And having a really extensive, deep understanding of public key cryptography and PKI in general is very core to even being able to talk about zero trust, let alone implement it for a company, including a small one. So I am spending a lot of time doing it. So this thing here where you save your private key offline, that's what would be facilitated by an HSM, a hardware security module like this. So we were looking at game running. Yeah, the game of life. So so this is the device I'm going to buy eventually, and there's a lot of applications for generating certificates, obviously, from the command line, including kubeadm itself. So today, the goal for the next 3 or 4 hours is to actually pick a preferred method for generating certificates without an HSM and integrating those into my kubeadm cluster stand-ups, where we're like starting up a Kubernetes cluster. How would I do it? Where do the keys go? Where do I store them? How do I store them offline? Which tool do I use to generate them? Do I write my own script? Do I use Ansible? There's a bunch of questions, but if I'm ever going to be able to automate this kind of thing, I have to decide how much of this stuff overlaps with Kubernetes and how much of it has to be generated specifically for Kubernetes. And I mean, it's a big deal. It's not like, oh, just run OpenSSL and get this thing. It's a little bit more than that. So that's going to be the goal today. I imagine it's going to take me all 3 hours to get PKI actually set up on my system. And of course, you'll be seeing my private keys and everything. There's no way. It's not going to be an actual root CA here. This is for my internal network. I would never, ever stream this stuff, but it's at least going to help me get into the habit of doing it. I mean, generating a root CA is not something you do even once a year, let alone, once you have it for an organization. So having a pretend, scenario where you're going to do it for a company or you're going to help somebody, you don't have to be a PKI consultant to understand or appreciate that skill. So I'm at least going to do it once, and then I want to set up kind of a flow, and this video is going to help for me to later to sort of enter into the PKI thing, so that if somebody were to hire me as a consultant, so eventually I could confidently say, yes, I've set up my own PKI for here, I've set it up for this company over here, and etc. And I could say, here's the steps we're going to follow. You can validate those against any number of government standards for doing this kind of thing. I mean, it seems like overkill for a home lab, but that's the entire point of this home lab. In fact, my home lab is bigger than most, mid-sized companies would probably deploy. So it's good practice. Anyway, so the next thing we're going to spend most of the day on is going back to the certificates, and we already did a lot of examination of the certificates. So we'll just here we have a 509. It turns out we set up the syntax as YAML, but it's not YAML actually, but it gave us some help with the color, and we can see a number of things here. I'm gonna recap really quickly how to identify a certificate and a CA, and how to understand the difference. So, and I also actually, while we're doing this, I want to diagram very quickly the difference between the default certificate, organization and hierarchy that's generated by kubeadm from what a good one would be that you actually did it yourself. I think this is important. I think this will lend itself easily to our drawing here. Okay, so this is, I guess we could say good. We'll say this is kind of preferred. How about that? Preferred. And I'm gonna make that green or so. I mean, tough decisions here, right? So this is, what the hell? Why can't I click you? I want to move you. I want to move it. Move it. Can I rotate that? That would be fun if I could. Can I? Please let me rotate you. Please. No rotating. I don't know Excalibur very well. It's kind of fun tool though. How do you rotate it? Rotates. I'm guessing here. Oh yeah, there we go. Preferred. All right, so, and then we're gonna, oopsie. Okay, so there's the preferred one, right? And then we'll set up the default. So we'll put one of these lines here. Because I wanna make very clear why. Actually, I kind of want this diagram because I'm gonna show this diagram to my people at work, and like, this is why I think we need to rethink our certificate policies, and you know, and do them right, which I don't think they're done right now. And where's a kind of a, there we go. Yeah, I like the really messy one. That's much more fun. Yeah, let's do really messy. Really messy. All right, so all right, so we actually, first of all, don't have a top level. So it's actually more of this kind of thing going on. And we're going to actually show all the certs that we have right now. Okay. So starting with the CA dot, which is, it's wrong in the documentation, we found out. So it's CA dot, oh wait, X509, CA.cert. So CA.cert is the Kubernetes cert. So this is a CA, and so it's called CA.crt, and it has the name Kubernetes. That is the CN, or the CN equals Kubernetes. Okay, so that is a CA. I guess we could, I don't know, what are we doing here? Put this all in here. So that is a CA that we have. And now we're going to see everything it signs. Okay, so and there's a CA key file. That's the private key. So that's the thing that we need to save. You know, and I do want to capture that. So let's do that. We'll call this, we'll put this as like it's private key. Right, and then it is, we need some more text in there. Text, yeah, we'll put some text in there. Wait, maybe we can just copy this one. All right, so this guy is, we have ca.key. And then that is, that goes over here. So that's the private key. These two go together. I'll put this on some line, I guess. Let's do that. Okay, so that's the main default thing that is created by Kubernetes when you do kubeadm init. And if you don't specify anything else, it'll make this for you. If you have stuff in the directory, by the way, it'll use the stuff you put in there. That's what we just found out. It was quite a revelation. So I'm going to copy this thing here. We'll call this the default. I mean, yeah, I could say. I'm going to do it, make it red, because I don't think it's safe, honestly. So, so you get a CA cert. So that's the main key, the certificate, and then the private key, which are not the same. They're all in PEM, which we found out just stands for something exchange email. It's just the PEM is just something that has been base 64 encoded and has the dashes and begin and end thing. It can be a certificate. It can be a GPG key. It can be a private key. Anything. There's lots of things that use the PEM format. So that's what that is. Okay, so we have a key pair. We have the SA public and private key pair, which is for service accounts. That is totally different. That is not a cert. So it's just a key pair. But I do want to demonstrate that. So that would be 2 of these. So it does not, the bigger ones have metadata in them. So like this doesn't. So this is, we have our like key and pub, which you could call the key private. We use private and pub, but not here. So actually, let's use this one as key and this one is pub. This is just a pub key pair. It does not have any metadata. So that's just a key pair. We'll actually make that a different color. Make it like, I don't know, some other color. So this is SA for service account and SA.key. So that's just a key pair. That's not a certificate. And I don't know how many times I have to say that, but maybe it'll sink in finally. Actually, let's put this one. I'm getting kind of anal about how I want to organize this. So let's do this. Let's put them like that. How about that? All right. So that's a thing. These are not related to the other ones at all. There's no, because it's not a certificate. So there's no relationship between these credentials and this type of thing. So this is just a pub key pair, pub private key pair, and this is a certificate. And the certificate has a public key, which is this part, that is encapsulated with metadata in our X509 certificate format. That's what the YAML-like stuff is. And then you have this ca.key file, which is just a plain old PEM file containing nothing more than the private key. And traditionally, that does not live on your system. Once you get everything set up, you should take that off your system so that anybody who gets access to the system can't generate their own things. And that's where the HSM comes in. Okay, so we're going back here. Let's see what else we have. So this list, by the way, of certificates that we're going through, we're actually looking at them. But if you wanted to see them listed in the documentation, there is a page. It's not, believe it or not, it's not in the Getting Started guide. It was very hard to find, but if you find the PKI Cert certificate page, PKI certificates and requirements for doing advanced Kubernetes, then you can do this. It tells you how to do it. But the reason this is nice is it does have a list, albeit inaccurate. This is not Kubernetes-CA, it's actually Kubernetes, and the default CN is not etcd-CA, it's actually etcd, so this is completely bullshit. But even though this is the only documentation you can use on the certification exam, which continues to be a source of frustration for me and everybody. I mean, if you were asked on the test, what is the default CNN for the default certificate, which is a very honest, possible question. And if you answer Kubernetes-CA, you get it wrong. But that's what the docs say. And whatever. Okay, so, I mean, do you think they would keep that shit up to date? At least that. Something as important as that. You think they would at least keep that up to date, but no. So here is a list of all the certificates it generates, which, it's actually not even complete. I just showed you there's an SA in there that they don't even list here. It says here, right? But they could have went ahead and listed it here as well. Anyway, there's just a ton of problems with the documentation. So, so that you can go to certificate key management, but if it's someplace around here here they are. Here are all the certificates like listed, bulleted, pointed out, right? And these tell you the relationships. We went through this ad nauseum when we went through the Kubernetes thing. So there's effectively a mutual TLS certificate pair, so that the API server can initiate communication with the kubelet, and so the kubelet can initiate communication with the API. And so there has to be 4 total certs for that to happen. There has to be a client and a server cert on the API. There has to be a client and a server cert for the kubelet. And then you have complete peer-to-peer communication, which everyone was saying yesterday is the definition of mutual TLS, which is MTLS, which is what people talk about. So that's 4 certificates right there. Okay. Then you have to have a client certificate for the CM to talk to the API. For the controller manager, you have to have a client and a server certificate for the etcd, because etcd communications needs to be initiated. So you have that kind of MTLS thing going on here too. So that means that etcd has to have 2 certificates, a client and a server certificate. The controller manager only needs 1 though, because it's only initiating communications to the API server. The scheduler itself also needs a cert, a client cert, in order to talk to the API. And then there's something else. It's not present here. This is an incomplete diagram. There's something else here called like an API extension server, not custom resource definitions. That's not it. But if you wanted to add on another API extension server, that would also need something called a front proxy, which I'm just learning about. It would need something called a front proxy, and that itself would need a client cert in order to talk to the API, just like everything else. Everything that wants to do anything in the environment needs to talk REST to the API. Yesterday there was some question about whether some of that communication is using gRPC over MTLS versus just regular REST requests. But I mean, as far as I know, and as far as everybody said so far, everything is still REST. Somebody else also told me that REST is actually faster than gRPC sometimes, depending on the infrastructure, the connection, which was news to me. So that's a rabbit hole that I went down yesterday. You can go read it, watch that if you want. We don't have a cloud provider, so we don't have a cloud controller manager in my environment at all, and never will. So that explains all of the keys that we have. This is a sample from Tinyfile about how to generate using OpenSSL, which is harder but more standard. And we'll return back to that. Let's go back to the certificate list. So having gone through that list, we can just review it here. A client cert for the kubelet to the API, kubelet to API, client, kubelet to API, client, server, client, server kubelet to API, server API, server certificate for the API, anything connecting to the API, client cert for the administrator. Oh, there's one other thing. So you need any of the administrators, if you have any, need certificates, right? So this is to prove that they're administrators, right? You probably are not going to use this long term. I actually spent a month or so writing our K-login tool in Go that authenticates against Keycloak and then uses OAuth to resolve ultimately in the back end to a Kerberos driven OIDC provider. And that is generally how everybody is going to authenticate to the server using role-based authentication and authorization. I don't remember which one the A is in RBAC, but whatever. So that puts us in a position where you're ready. But you can, if you want, you can issue certificates to administrators who can bypass all of the admission controls in RBAC and just go straight in. And that is what is by default inside of the admin.conf file when you first initialize a cluster. You get that admin.conf, and you can put that thing anywhere. You shouldn't, because it has basically a root password in it that can get open carte blanche access to everything in the cluster. And there's strong warnings against it. But that is one. But if you wanted to have more granular administrator access, and most people are not going to use these certs, but I mean, it does create it. So anyway, client certificates for the API server to talk to the kubelet. So this is so the API can talk to the kubelet. The client, client certificate for the API server. The API server needs to initiate communication with etcd, which is the brain of Kubernetes, and the client certificate for the controller manager needs to talk to the API server. So the controller manager is the thing that's really doing everything. That's the everything is a controller at the end of the day inside of Kubernetes. It's anything that's doing anything is a controller, and it uses the controller model architecture, which is an entire different topic, but it's a design principle for code called the controller model, and everything's a controller. You can if you want to extend to Kubernetes, you're essentially writing a controller in some form for a CRD. So anyway, and then you have the scheduler needs to be able to talk to the server. The scheduler only needs to tell the API server stuff. Writing controllers is hard, yes. And so the client config to talk from the scheduler to talk to the API server. So back in our component cloud, so the API server doesn't need to talk to the scheduler. The scheduler needs to say, yo, go run this thing. And frankly, the controller manager is like, hey, we have stuff is in a certain state, and I don't know how it communicates, but somehow the controller manager and the scheduler actually communicate, because the scheduler is the one who actually tells Kubernetes to do stuff. This is like the one who's controls, as I understand it, this is the one that controls telling the kubelet to actually do work. So, and the controller manager, I think, spends most of its time communicating directly with this. You can do whatever you want in a controller, but I have a feeling that most of the controller work, I'd have to look at the source code, is when it has something to do, it informs the scheduler or vice versa, and the scheduler initiates connection to the API server, and the API server says, yo, go do something, right? So that's why the API server does not have client certs for the scheduler or for the CM, the controller manager. It does, however, have client certs for etcd, so it can initiate communication with etcd. etcd is not pushing communication to anything, but the API server has to regularly go there and get stuff. In fact, I think, well, I don't know, we'll see. It's so not good at all, actually. So that is a excruciating overview of certificates. Again, understanding it is super important. So I'm repeating it many, many times so that it sinks in for myself. And so there we go. And then we have the client and server front proxy. Front proxy certificates are required only if you have kube-proxy to support an extension API server. So kube-proxy is the thing that brokers communication. There is a kube-proxy, but you almost never deal with it. They actually cut it out and listed independently here on a node. That this is not how you would ever see it. You would think by looking at this that the kube-proxy is a separate thing. It's actually a part of the infrastructure. If you go to the endpoint, by the way, and you try to list all of this stuff, so you do kubectl, get all the pods or anything, and from the system. Oh, I need to export my thing. Export kube-adm. I just want to show you this stuff because I believe kube-proxy is a static pod. Anytime you encounter it. Template PV. Oh, right. kube-adm equals etc kubernetes admin.conf. You'll see people doing this all the time in tutorials because when you first set up a cluster, it's the only way to set up authentication into the cluster. It's not meant to be used in general. It's only at an early stage thing. You should eventually delete it. But yeah. Get pods. Oh, because I'm root. Oh, why is this kubeconfig, not admin? Whoops. That was surprising. Here we go. So temp shell is a pod that I put in there. Core DNS is the internal DNS, which is weird because that eventually needs to be fixed. etcd we talked about, API server, controller manager, controller. these things are static. That's because they don't have these random numbers. I found that out like 4 days ago. I've always wondered why I was doing get pods and some of the pods did not have fancy numbers at the end. And it's not just because they're, when I saw these, I originally, like years ago, I thought that the reason that this was not a random number was because it was a pod that was deployed that not as a part of a deployment, which is true. A static pod is a standalone pod. So temp shell here is a pod, right? The difference is, I want you to notice this. This is actually really important. So this temp shell is actually a pod. It's a pod in every sense in the Kubernetes cluster, but it's not static. A static pod always has dash and then the host name after it. And the way you could identify a static pod. So I'm kind of hung up on the static pods thing because honestly, I did not understand static pods fully until last week. And now I really, really understand how significant they are. And they are very significant. They are, every major component of the architecture of Kubernetes is a static pod. So that means understanding what that difference is super key to understanding it. Review the standard static pods of Kubernetes components. Okay, so a static pod is just a pod that runs without being managed by Kubernetes. As weird as that sounds. It's external to Kubernetes, even though it's in Kubernetes. It's actually, the thing that we're looking at isn't even really there. This is what's called a mirror. It's a mirror of a static pod that's been put into Kubernetes for the sake of management in terms of viewing it only. You can't do anything to it. And it's also been, you can actually look at it. There is no spoon. Exactly. So we're going to do get pods. Let's do get pod, like etcd control 1. We'll do -a. Just across all namespaces. Okay, fine. -n kube system, which is the Kubernetes system namespace. All right, but check this. So we can do, let's do an edit on it. Yeah, you won't be able to edit it, but I do like to do this sometimes because it's easy to read it. We could just do edit -n. There's no way you should ever be able to edit this, right? I want to show you can't. And it should probably complain. It was like, no, it's a static pod. It's just a mirror. You can't touch it. Okay, no. So I mean, it's for better or worse. Sometimes I use the edit command because it opens it up in YAML right away. And it's really easy for me to just view it instead of having to do -o YAML and then open the file. It's somewhat dangerous to do this because if I make any changes, they will be applied immediately. But a lot of times I do want to do that. So I am going to use the edit for this. Please edit the stuff below. You can't. Watch. If I try to edit it, it'll say, nope, can't do it. Runtime default security. Let's see. Config harsh. Somebody reported here that one of the annotations will tell you that it is not an actual pod. That is in fact a static pod, but I'm not seeing it. Comps. Let's talk about. Yeah, I don't know. Configure source file. I wonder if that's it. Kubernetes pod runtime default. This is very interesting because it's namespace is kube system. Tier control plane labels etcd. It doesn't tell me anywhere it's a static pod. I was misinformed. I was definitely misinformed. This is definitely not a static pod. Nope. So let's look at one that we know is a static pod. QVIP. QVIP control 1 is, we know it's a static pod because we set it up as a static pod by default, by hand. If this doesn't say static pod in here, okay, so it says config source file when it returned dash health. Yeah, that's kind of funny. Namespace kube system. node controller one UID. I was misinformed. Someone said it said its type was static in the metadata annotations, and that's not true. So, this is why I have to like back everything up with my own validation, because everybody's got an opinion about how stuff is supposed to be and what it's working. They're all pulling out of their own memories, and they're remembering things poorly. Yeah, this is a little frustrating. This is not okay. So let's compare these YAML files to something that's not static. So it's not just that. It's people's memories of how it works is also trash. So I have to really filter through a ton of shit. It comes down to just experimenting with it and validating for yourself, because even something somebody told you was true like last week is not true right now. No. I mean, look at this. If I do, okay, so get pods, we know temp shell. It's a pod that's not working yet because we don't have a CNI installed, because I'm waiting to get the certs right. But we can go ahead and do temp shell, and we know that's not a static pod. So we're going to study the annotations of an actual pod versus the annotations of that's not in kubesystem. That's in the default namespace, which is normally not a place to do anything, but we'll do it. Okay, so this, as you can see, it does not have the same annotations. Labels run temp shell. Okay, so it doesn't have any of those annotations at all, which I am really lost on, because this does, okay, so Kubernetes config.mirror. Okay, so this, remember I said that static pods are mirrors of other things. There it is, config.mirror. If it's a mirror, it usually will be better than YAML for all that. No. Totally strong disagree on that. Config.source file, config.hash, config.source. You can't do composition in JSON. We'll start with that. And so I'm guessing config source file is the way to indicate that it is a static pod. I'm going to confirm that on the internet right now. Okay, a static pod. And that should, I'm going to go see. Creating static pods. Get past all this stupid outline stuff. Somebody's saying they like the outline of this documentation. I hate it for this very reason. Static pods are managed directly by kubedaemon. Yes. I'm going to add this again. I mean, lots of things here. This is like all my notes here. Owned by the node. I don't know. I don't want to guess. I want to read it from the questionable documentation. Static pods are always bound to the kubelet on a thing. Basically, I want to be able to do a get pods and filter all the static pods out. And I want to know what to filter on. The kubelet automatically tries to create a mirror pod on the Kubernetes for each static pod. This means the pods running on the node are visible to the API server but cannot be controlled out from there. Yeah, if you're seeing it at all from kubectl, you're seeing the mirror. If you're not, it's very possible to run a static pod with no mirror. Like if the mirror got screwed up, you could end up with pods running over there and never know it. And that's, I think, why crictl comes in and things like that, because if you think there's a chance of that, SSH into the endpoint node and then look directly at the pods running on the container with crictl, which is probably something I should do. Let's try that right now. Yeah, I mean, where are we? Are we here? All right, so yeah, let's try that actually. Let's do crictl pods. There we go. So crictl gives us all our pods. This is something that comes with Kubernetes. So we have kubevip control 1 in kubesystem. We have all of our other controllers, core DNS. It does not tell us what type they are. I don't know how to do this, so we're going to try this. Unsupported format wide YAML. Okay. So state sandbox ready. Namespace cube system runtime handler sandbox ready. We have the annotations. File. This is interesting. Container name pod. You seen this one? They're all pods. They're all pods. No, not for this, because I'm on a system that doesn't know about it. Yeah. So annotations. Config.source API. Look at that. Okay, I think we just answered the problem. Okay, so we have. This is I don't know what pod this is. Oh, kubedns. So this is core DNS. Okay, so kubedns, which is core DNS, shows its config source as API, which means it's not. That was properly configured. Okay, this is super interesting. And then we have, yeah, there it is, core DNS. And then we have the other API. What is this, core DNS again? Yeah, there's two core DNS. We know that from the other one. So there's not supposed to be two core DNS on the same system. It's only doing that because we initialized kubeadm on the machine. We actually have to delete one of those pods so that core DNS will distribute across multiple code planes. So we don't have, both of our pods running on the same machine, which just removes our HA completely. You have to explicitly do that, by the way. It doesn't do it by default. You have to go do it. LBG was telling us that the other day. So, which is a pain in the ass, but whatever. So we have annotations. So this is another. Okay, so kube-proxy is a real pod developed from the API. We have, okay, and then we have the same information we can see from kubectl. We can see that we have a file here. The reason I wanted to use crictl is because if for some reason the mirror isn't created, you would not be able. The mirror gets written to etcd, so it can be queried from anywhere in Kubernetes land. Anywhere you can use kubectl, you can see the mirror. But as you can see here, you see how there's no. You see here how there's no configure. This is so cool. I have to take a note about this. I have to make a note about this because when you access a static pod from crictl, the annotations do not include the stuff about it being a mirror because it's the real thing. This is really interesting. I mean, it does sort of make me. I mean, if I use kubectl, okay, so if you use kubectl, it's going through the API to make the query. So it's limited to what the API can see. If you're doing crictl, you're bypassing the API and you're going directly to the containers that are hosted on this actual machine. So that is a super cool discovery for me. Crictl shows bypasses API when looking up pod information. No config.mirror I'm going to put no config.mirror annotation. Okay. Forget pod. Okay, that. I really love that. That is really cool. I don't care. It's a waste of time, Copil. It's probably cool and all, but the entire world is using YAML and JSON right now, and I need to stay with that and not waste time learning other cool stuff. There's way too much to be done using the existing standards. Everybody's always inventing a new configuration format. It's always a new one on the block. And, at some point you got to pick one and just get work done. So anyway, so let's do the, Yeah, let's do this again. And so as you can see, this has config.mirror, and it has config.source as file. Okay, so okay, config.source file means static pod. Config.source API means regular pod. kubectl. Etsy Kubernetes manifests. Okay, so that's cool to know. I mean, we're kind of off the other track, but I like that. That makes me feel more confident in the whole static pod thing. Anyway, so I was trying to show that these other pieces. Wait, kube-proxy. I wanted to see if kube-proxy's embed. I wanted to see if kube-proxy was a static pod. That's what I was looking for. So that's what led me down this path. Let me do that again. Let's do let's go search for kube-proxy. I have a feeling it is just by the name. Oh, look at that. Kube-proxy not found. Interesting. There's no kube-proxy because there's no kubelet. That's interesting. That's interesting. So if I go to one of the pods that has it has to have a kube-proxy. That has to be a mistake. That has got to be a mistake. Yeah, there it is. Okay, so kube-proxy is an actual daemon set. What? Yeah. And this other one's like screwed up. That's weird. I wonder if I can delete it. I mean, it should not be screwed up like that. Kube-proxy dash th9. I don't have completion on apparently. What? That's really weird. It must be a daemon set. What the hell? kubectl get all dash a. This is everything. Hey, Bill. Yeah, programmable configuration files are a horrible idea. Because you can't, the whole point of a configuration file is to keep it declarative so you can compare it against the policy enforcement. And if you've got business logic in there, then your auditability drops into zero because you'd have to run the thing to audit its results. The reason declarative configuration files are going to remain the standard forever is for that reason alone. I mean, it seems to make sense that it'd be easier as a developer or as an implementer to do that, but if it's not declarative, you can't audit it. So, again, I'll default temp shell container D. I'm guessing temp shell and this container creating is trying to, I think temp shell is trying to fire off a kube-proxy, and that's why I can't do it. I think there's some sort of relationship there. I don't know that, though. I don't know that. That's probably why I can't delete it. But anyway, I kind of wanted to see what the type is. The kube-proxies should be pods fired off from a daemon set. Yeah, let me do well, let's do all again. Yeah, I know it doesn't fit on the screen. I hate that, but whatever. maybe we could do dash -o-YAML. We could read it easier. Let's do that. Okay, so, or we could do, could run that through, I mean, temp foo.yaml, temp foo.yaml. All right, so we have a pod, temp shell. We know about that one. What else we have? We have next item, API version 1. We have another pod, core DNS. Okay, we know that. That's a big one. Wait, did I run past it again? We could probably just search for API version. Yeah, what's that? Okay, so we have an API version 1 kind pod, another pod, core DNS, which is a replica set, which is from a deployment. Okay, then we have a static pod, which is evening session. I mean, I kind of do, but not right now. I'll after this little thing here, I'll do another break. I do need to do the break, so this is a node, kind node. I've never seen that before. I've never seen a kind of node for. Oh, that's the owner. The owner is the node that owns it. Oh, a node is a resource that represents the node. So the owner is the node. My node is evil. Lol. Phase running pod IP. I can name stats. Okay, so we have etcd controller 1. And then the kube systems kind of node. Okay, so etcd is a static. etcd is definitely a static pod. Do I have plans? Oh yeah, lots of plans. Yeah, nothing I want to talk about right now, but yeah, you got to make the big bucks by being able to install this for somebody else and manage it. That's the main plan. If you don't know how to install Kubernetes, I don't think you should be working as an on-prem admin personally, and that includes me. So API version 1 kind pod. So this is another static pod because it's config source file. This is the API server. This is interesting. So the API server is running as a static pod. I would not have guessed that, but I guess it is. Okay. That's owned by the node. The node owns it. Okay. Control 1 is a node. I've noticed that all of my nodes are not fully qualified host names. And I'm actually concerned about that because I think that's because it's been resolving them according to my host file, which only has unqualified names. And I've been thinking about this for a lot. I think I actually need to do the fully qualified and then the short inside of my host file, rather than have the domain search criteria like you do when you resolve.conf. I think that's probably the right thing to do. I don't know though. That's a very interesting question. So anyway, authorization. I don't know if kubeadm grabs the host name or if it grabs, because the host name technically is not fully qualified. And sometimes I wonder if that's a mistake. I wonder if I should have fully qualified the name. I don't know. It's a big question though. So here we have what I'm trying to look for the kube-proxy on here, because we know there's a proxy on here, and I want to figure out if it's a static node. I don't think, actually no, I'm pretty sure it's a daemon set, and I could have gone right to it, but I'm kind of going through all this stuff just as a reminder before we get back to the PKI stuff. There's another static pod. The controller manager. Okay, that's a static pod. There's how controller manager got started. Oh my god, look at that. Bind address, everything that it's doing, root CA file. See that root CA file? That is why we need to bring the cluster up again without, I'm not going to reconfigure all my stuff. I'm just going to run kube and edit from new, because this, we need this to point to probably user local bin CA certs certificates, and I'm going to put the certs in the right place that's expected on any system, not just for Kubernetes. Now you can copy those files in there. It depends on what you point your certdir at. And I'm hoping I can get away with pointing to the CA certificates directory, but I don't know if that's a wise choice. In fact, I should probably go read that right now. Assert dir user local share CA certificate. Batch automated generate certificates manually. Kubernetes RecCN specifies the common name for the CA's new root certificate. What? Generate a new certificate authority batches. Okay. Using Google managed SSL certificates. So apparently knowing how to manage certs using the kubeadm commands is required for the certification. Is how to mount Kubernetes root CA into pods. I like this one. Let's read this one. Identify the message in blah blah blah. Common requirement of container-based images to provide a CA search, for example, to install CA certificates package. I believe this is an anti-pattern. Revoking or adding new CA certificates requires rebuilding and redeploying all workloads. If my person wants to add our internal CA or decides we don't trust a standard CA, we need to build our own images. This is poor visibility into which CA search are trusted across the cluster. That's true. Related problem is how to mount Kubernetes root CA certificates. What you would expect to happen. There are new opportunities for Kubernetes to provide some value out here, which supports the cluster name management of CA bundles. It's already feasible with some extent by putting CA certificates.cert bundle and config map and manning into the container. Woo. But there are some shortcomings supports, no cross namespace config map references, so the CM needs to be cloned on every machine. That's horrible. Every pod spec needs to be modified to mount the CA. Ugh. Have a single cross cluster scope of CA data. Should be easily added to that, yeah. Huh. Yeah. That's very interesting. Yeah, looks like there's some considerations for where to put the certs differently. Kubernetes add CA certificates to pods, trust a root. I believe there is a location to the search by default. Add self-signed search ATL certificate in Kubernetes pod. Recently been working with challenge related to one cloud component. The self-signed certificate and has a certificate as well as other certificates in the certificate change is not available with trusted CA root. Thus, my application running in pod is not available as trusted CA root certificate. Thus, my application running in pod was ending up with a invalid certificate issue. To be more specific, my app was consuming Redis cache for a well-known public cloud that was using Let's Encrypt certificate, which has certificate chain having DSD root CAX3 certificate, and thus I never faced a problem. And now the cloud component got upgraded and its new version started using self-signed certs with no change certificate of any existing CA. Thus, my application, which has been working so far, started getting runtime errors because it couldn't get it. That's the thing with cert chains, man. That's a pain in the ass. It does make me wonder if I even want to stick it to cert chain. Because if I do, everything has to be in the cert chain. I can't add new things dynamically without having the root CA. So it might be a bad idea, but everybody said it's a good idea so far. So, whatever. Where is proxy? All right, so proxy is a regular pod, really? Oh, it's a daemon set. Okay, I figured. So proxy is a daemon set, and kube VIP can be run as a daemon set as well. So that makes sense. A daemon set is a pod, that one pod per node, and you only get one daemon set per node. You're not allowed any more than that. So that makes a lot of sense. Being a daemon set, that means that it's actually not a static pod, and that's why we don't see any of the annotations for it that we would see. In fact, if we do that now, if we do get, let's do edit pod kube-proxy, edit, I can't believe it doesn't have completion. Okay, there we go. Proxy, tab. Come on, baby. Edit kube-proxy. It normally will get it. As a daemon set. I could do a DS instead. Yes, there is. All right, there it is. Daemon set, kube-proxy, annotations deprecated, daemon set template generation. Okay. Pod. I know there's no pod named that, so. There we go. That's what I wanted. Kube-proxy. Whatever. All right, there we go. There we go. See, no annotations. So that's how we know it's not a static pod. It's a daemon set. And it'll say the owner is a daemon set kube-proxy. So that's good. Then we know the hierarchy of that. All right, good. That's all I wanted to know. We were talking about component interactions and whether it needs client server or anything. So there are no kube-proxies running on the control plane. Nope. Well, that's not true. It's just running as a daemon set. crictl get pods. Pods. So this is the same information, just not from kubectl. So we have our VIP, etcd, kube scheduler, API. So this has a server and a client cert, no cert, client and a server cert, client cert, client and a server cert, client cert, no cert. All right, so that explains our interaction here, and I feel like I really have a handle on that now. So here's the breakdown, and then we have the users, which are not included. So okay, so let's go back to our drawing of this, and I do want to take a break, so I'm going to walk up and take a little break. Here's some devil music. All right, so here we are again, and back to our diagram. So we've got the CA, which is got the name of Kubernetes property. This is a self-signed certificate, which means that it has the same issuer and subject. We have a key pair for the SA. We have, let me see if I can go there. 3. Back into etc Kubernetes PKI. I had a command going on for this. I deleted it. Where is it? There it is. Okay. We have API server.crt, which is this one. So this is, as you can see, it's issued by Kubernetes. So this is signed by the one that we already have on our diagram here. And this is a new one though. So this one has a CN equals API server. That means it is an actual cert. And so it has a key as well. So API server.key, that's the private key, which I think has to stay here. I don't know. I think the private keys can be taken off of the system. I don't know that though. Hey, so let's add that to our diagram. We have, so under here we have another pair. We'll make this on a different color though. Make it purple or something. Actually, how about something a bit more dramatic? I don't know. I mean, this is the API one. It doesn't matter. Not that though. That's fine. We need more colors. Gosh dang it. Can we do that? I guess not. Oh well. So yeah, this, okay. So this is, it's not CA key. We have this is API server. API server.key. And put that over here, I guess. The CN here is as API server. Hey, how you doing? API server. And this is in API server.crt. And it is not a CA. No, it is not a CA. So this is a CA. This is not a CA. This is just a cert. And the way you can tell that, we already know this because we looked at that before, but the giveaways are this. Down here in the X509 extension section, it tells what kind of thing it's used for. You can see here that it's a CA equals false, so it is not a CA. If it were, it would be true. And we also see down here the DNS names and the IP numbers, and this is causing me to rethink my network topology and naming, because as you can see, it put Kate's here as opposed to kates.example.com or whatever my domain is, and that's kind of a problem actually, because that means, I mean, I don't know. I feel like this needs to be fully qualified. All these other fully qualified domains are qualified to point to stuff within the cluster, but the stuff on the top level, control.1, control 1, which is a host name, and Kate's, which is the client endpoint entry point for the API, which is load balanced, these should be fully qualified, and they're not. So it is interesting though that Kubernetes is one. So if you actually wanted to refer to it as Kubernetes, you could do that. This makes me rethink the entire cluster deployment based on the names that I'd set up, which I believe are now incorrect. So I don't know if that's going to make it so that my domain names are going to be really long when I do everything, but even so, that would probably be fine. So like like right now it says Anton homelab, right? Based on what I'm changing it to, it would be something like anton.lab.rdbx.gg, and then that would be a little bit longer. But as I'm switching between machines, that would actually be easier to watch as on the stream too. So I'm glad I went through this. Ironically, it's the certificates that are triggering my changes in how I want to deploy my network naming and stuff, because the certificates are fundamentally tied to DNS names. So that is a big deal. So don't be me. Decided to redo home lab network naming naming and default search domain. So I'm going to redo all of that. That means that I'm going to be ripping some stuff down. I don't know if I'm going to do it right now or not, because I kind of want to get my handle on how to generate these certs, and then I'll redo the network gaming, and then we'll come back and do the whole init thing from scratch, having all the right answers for this init file. So, like, for example, is the cert directory going to be etc Kubernetes, or is it going to be user local share CA certs, that kind of thing? I'm pretty sure I'm going to make this user local share CA certificates, and I'm going to put my certificates in there to go with that. I don't know if I actually want to upload certs anymore. We might, but maybe not. I mean, we're not going to print the keys for sure. Service cider, the pod network, is it all there? So I actually changed this example.com. This is going to probably change to lab.rbx.gg 6443, and that's going to be my internal domain from now on. Because I own rbx.gg, so there's nothing there right now, but I haven't updated that in years, a year actually or more. But so again, it all focuses on this kubeadm init command. If you can focus on getting a kubeadm init command that is good, it will distill all of those other decisions you have to make about your home lab deployment, about any lab deployment, because all of those numbers and answers and domains and arguments are the result of some pretty serious soul searching about how you want your architecture to look. And that includes etcd. I mean, etcd is not here right now. I think etcd is stacked by default. API cert extra sans. No, we don't need that. Subject alternative names. No. Can be with IP addresses or DNS names. Oh. API server bind port was just 6443 by default. You can actually have more than one Kubernetes deployment running on top of each other if you really wanted to. It'd be kind of dangerous, but you can do it. I don't see how you would share your container runtime that way, but you can. How's it going, Blonde? Config path to Kubernetes configuration file. Yeah. Control plane endpoint string. ACRI socket, we already have that. So yeah, if you wanted to run more than one, you could actually run two container runtimes at the same time. That would be weird. It'd probably not work, but I guess you could do them with a different socket. Strictly speaking, I guess you could do that. Rootless control plane. False beta, ignore prefab warnings. Image repository, we're using the public one again. I actually am going to put this in my thing because I want to eventually change that. I want it to be very explicit that I'm using an external source. I'm not going to do air-gapped, but someday I want to do an air-gapped deployment. Just to go through it. Kubernetes version, no, that's not it. What am I doing? Image repository. Image repository. Kates.gcr.io. Okay. No name string. Specific Kubernetes version for the propane. I chose 1.24.26. I don't know if that's actually going to work. We're going to find out. Specify the node name. Huh. I wonder if it gets that from the host name. I'm guessing. Patches. Path to directory that contains files to patch for the extensions. No, we're not patching it. CIDR, specific IP range. That's our IP addresses. We'll leave that how it is. Alternative domain name services. Nope. Let's do cluster.local. MyOrg.internal. Service domain name DNS string. I'm going to put that in here. your streams? Oh, that's awesome. Yeah, I'm not doing that right now, but service DNS.domain string cluster.local. Look, thank you for that. That's good. Yeah, I'm trying to keep it real. Appreciate you doing that. All right, so service DNS domain cluster.local. Skip certificate print key. We're not doing that. Skip phases. No. Skip token print. Skip printing the default bootstrap token generated by Kubernetes. No. We're gonna use that. That's fine. We can always get a new one, but bidirectional trust between the control plane and the format is blah. Yeah, you can actually set your token if you wanted to. Yeah. It doesn't have to be that big a deal. So, token duration is 24 hours by default. Upload certs. Kubernetes search secret. Okay. So, it's just, I got kind of distracted by my init again, but now I feel like I know what I'm doing a little bit better. Let's go back to the certs. So, and all the reasons I need to change my naming, I already got that down. All right, so we were in the middle of drawing our diagrams to show the relationship of everything to everything. I mean, we should probably make these gray. I'm guessing that would be better. Yeah, let's do that. Let's make those like, how about gray? Gray. No, let's do this. I'm making pretty pictures. Pretty pictures. All right, so yeah, let's do that. So with the preferred, now we can start drawing some more pictures here. I'll put this over here. So we do have, I mean, I'll make that back to this color. So we have the certs that sign the API server. Yeah, let's go in here and look at that. That's how we know it was signed. Now let's look at the next one. So we have the API server etcd client, and this is interesting because it's in here, right? And it doesn't look like it belongs here, but it does. etcd-client. So this is, and we'll see right away. Okay, so it's not a CA, so it means it's an actual cert that's being used by something. It was issued by etcd-ca, which, contrary to the documentation, is, in that case, it's actually consistent with the documentation, where the Kubernetes CN is not. So what does that mean? That means we have another one of these, another top level. We have another top level CN that doesn't report to anybody else. Okay, so, and we're going to change the color on this. Let's make it etcd. We'll make it red because, well, how about this? I mean, it doesn't matter. I got here purple. Okay. So this is the CN here is, I mean, we haven't looked at this one yet, but it's implied by the issuer. So we have etcd-ca, right? And it lives in etcd slash ca.cert. So watch. If we do the same thing on this one, we should get, I mean, let's go into the etcd directory. etcd is a separate component, pretty much. It's just, you know, it used to be a totally independent component. It's not anymore, but it used to be. So here we have ca.crt, right? So that means it's the top level, which is why it has its own directory, probably. So here we see a self-signed cert. The issuer and the subject are the same. We can configure, we can validate that it is indeed a CA because it says true down here. We see that it does not have DNS names or anything like that because CAs are not designed for that, but it does allow it to certificate sign. That's why it's got this extra usage besides these other two that everything has. So that's what a CA looks like. And we can see that it's a top level CA, even though that there's nothing above here. And that's why this is the architecture that we probably want instead of this, because this is the default. Okay, so then we have, okay, so what does that sign? Well, we know that it signs, I guess we could keep this in the green. Let's make this in green so they match. How about that? What kind of green is that? Is that it? Nope. How about that? So these two match. Okay, so this guy, actually, there are a few other things that it does sign, so we'll get there. But this guy gets signs something else. It also signs the API server.etcd client key dash etcd client, and API server is actually API server dash etcd client, right? And this is API server dash etcd dash client. And of course, that's not that color, that's purple. Hey, thank you for the sub, Slinky. So that is actually this color. So, and strangely enough, that lives in the top layer. It does not live down below in the etcd land. So yeah. So we'll copy this guy, and I'll tie these two together. So this guy, we'll put this down here. I'll put you up here a little bit. All right, so there we go. I mean, for right now, I guess we could have it be 1-to-1. I don't know. Lots of like writing there. But anyway, so that's our second cert that we're examining. What the hell? All right, so we looked at API server.crt, we looked at ca.cert, and we looked inside of etcd at etcd/ca.cert and ca.key. And actually, I should probably put etcd/ca.key. And then we have the API server and this one, which actually goes in this directory, but not really. And then we have the API server key, which we already looked at. We have the kubelet client. So this is the kubelet client goes on all the things that have a kubelet, which if you go back to the components diagram is over here. So anything that has a kubelet, including the control plane. I didn't know that when I started. When I started, I was like, wait, so there's a kubelet just for the endpoint nodes, or is it for the control plane nodes as well? It's for both. You have, so if you were going to think of it in terms of object-oriented inheritance, a control plane node is a worker node in the object-oriented sense. So it has all of the components and static pods and everything that any other node would have, plus extra that make it into a control plane node. That is not obvious from the documentation. Okay, so then we're going to go through here. And so the API kubelet client, which any kubelet gets, including a control plane node, right? As I said, they have a kubelet. You might think that there's no kubelet on the control plane because there's no kubelet little diagram over here, but it has one, I promise you. It can't communicate without it. So that is a fact. I mean, let's prove that. Okay, so if I do CRI-CTL over here, and I do pods, I don't know if I'll have access. Yep, there we go. So as you can see, there's not a kubelet over here. Wait, what? That makes me confused. There's a kube-proxy, but there should not a kubelet. There should be a kube-proxy and a kubelet over here. That means I lied. Let's go try it. Let's go to an endpoint. Mini 1. All right, so no pods over here yet. What the hell? Why hasn't it got any pods yet? This should have pods. Hmm. Something's not right. Did I not install it on anything? All right, fine. Kube-proxy, kube server, CD core, tip shell. I could have swore we had... Yeah, it says mini control. Oh, it's because it doesn't have a CNI yet. Okay, never mind. Yeah, we keep waiting on the CNI. It can't talk to the API because it doesn't have a node yet. It doesn't have a network interface, a container network interface. No, it's there. It just doesn't. It just can't talk yet. Yeah. Okay, that makes sense. I would have expected it to phone home. Yeah, I'm gonna try something. Get node mini one. Let's do edit. So create socket. TTL 0. Manage dash. Yeah, internal IP. Oh, that's cool that it tells you what type of IP it is. Type hostname. Allocatable CPU, 4 allocatable CPUs. Cool. Ephemeral storage. Yep. Is this for local CPU? Pods 110. It can run up to 110 pods. Shit. I didn't know that. I didn't know that was going to be the default. That's actually really good. Capacity CPU 4. 110 pods. What? Allocatable and capacity. Oh, capacity versus how much has been already allocated. Okay. Conditions, less heartbeat. No memory pressure. Kubelet has no disk pressure. Because it's not doing anything. Yeah. Node info. Machine ID. 1222. And we're going to be adding sources. That's cool. I mean, it seems like it reported in. Where's the status stuff? Cluster large. Oh, they have tons of like random stuff that's not tied to any documentation at all. Here's another one. No more than 110 pods per node. No more than 5,000 nodes. No more. Yeah, these numbers are completely bullshit. So says Krager. Yeah, the other day he was reporting. He's like, these numbers are total bullshit. You would never even come close to 5,000 nodes. Yeah. Yeah, we have cluster quotas actually. We have OPA gatekeeper stuff that says you gotta be running as root and everything. High availability, we checked this out already. And that's where you talk about staged, et cetera, et cetera. Yep. Yeah, that's a good one. Anyway, I'm curious because I was interested to see what's up with the CA over here. I mean, what were we doing? We were doing the API survey. We were checking to see if the kubelet, I could have swore a kubelet was required on the control plane nodes, and as it appears, that's not true. And that would make sense because there's no need to talk through. The kubelet contains the proxy, by the way. So that's another thing that people don't talk about. So when you do when you do apt install kubelet, you get a kube-proxy static node, a static pod by default. And that's what I was trying to show. So like if I do, by the way, there's a command, God, I have it in my notes someplace. There's a special command you can do that say, get me all the pods on a specific node. It's actually in my Zet. It's like, it's not completely obvious. See all pods on a given node. Wow, there's the last one. Okay, so there it is. That is the magic command right there. That is the magic command. And you have to do an A on this. Okay, so kubectl get pods field selector spec node name equals name. Oh, damn it. Did I get it wrong? Oh, we have to do -A to get everything. No resources found. Oh, we have to put the name. Duh. So we want them on mini 1. Okay, so those are the pods that are currently there that are registered in etcd. And it's trying to run temp shell. I can't do it because there's no CNI. And it looks like it tried to run a kube-proxy. Ah, I see. So it's trying to run the kube-proxy, which we know is a daemon set and not a static pod, on the target, on the kubelet that's running the kubelet. So I think that the takeaway here is that a kubelet is just an abstraction for, you know, all the files that it installs and the kube-proxy static daemon set. And the reason that the kube-proxy daemon set was unable to be created is because the kubelet does not have a CNI installed yet, which can be installed over the network, ironically. So because it's a container networking, it's not the networking between the pods, between the node, the API server and the kubelet and the kube-proxy and stuff, which really freaked me out. So the CNI, we need to install Calico on here and just be done with it. Because then we would be able to talk and this stuff could run. But it's confusing because the networking between a kubelet on a node and the API server is there. It's there automatically. You just need the certs for that to make that happen. You don't need any special plugins for that. That's just, you just need a network. But for the containers to talk to each other, and containers, of course, are the primary element of the pods. For the pods to talk to each other, and including the kube-proxy, which then sends communications to the API. So if you want any of your containers or your pods to talk at all, they can't do anything until you have a CNI, container runtime, a CNI, container networking interface. And that has to be installed, ironically, by using a kubectl command to apply a CNI that then the containers will then understand, and then the pods can talk to everybody. And one of the pods, the very important pod that it has to talk to, is the kube-proxy daemon set, because that is the one that translates all the pod communication inside of the little container runtime, kind of encapsulated in there, into something that goes to the REST API that can then talk to other pods on the network or services in Kubernetes and all that stuff. Because otherwise it can't talk to anything because there's no inter-pod communication. So that's why temp shell can't communicate with the outside world. Because as far as it's concerned, it just lives in this tiny container runtime. And there's no way to talk until we give it a way to talk. And then that is Calico or Cilium or whatever we're going to do for our CNI. We're not there yet. But that is why the kube-proxy is not showing up. And I think that's important for me to understand that, because when I look at the docs and you look at this component diagram, you're left with tons of questions like, what actually are these things, right? There is no kubelet. The only time a kubelet actually exists is when you're doing sudo apt install kubelet. That's it. In terms of like something running on the system, there is no kubelet running on the system. If I go to the thing, there is no, there is no, actually there might be a systemd service for kubelet. I don't know. Let's see. ps-ef grep kubelet. But I don't think there is. I think it's a static pod. I think it's a static pod, and I think kube-proxy is the only thing. So, yep, there we go. Oh no, there is a kubelet. Okay. I take it all back. So kubelet is a daemon. Kubelet is a daemon. Okay. So kubelet actually is a running, it has nothing to do, it's not inside of Kubernetes though. Proxy, the kube-proxy, which used to be an external daemon, and if you go to Kelsey Hightower's The Hard Way, all of that ancient stuff is based on starting up daemons for everything, including etcd and kube-proxy. They used to be their own daemons until, and I think before daemon set was invented. And then after daemon set got invented, now kube-proxy gets started up inside of the Kubernetes architecture as a daemon set, as opposed to a standalone daemon. If you wanted to, you could run a standalone kube-proxy daemon. It would just conflict with what your kubelet's going to do. So that's important. So when you see these little, slightly not hexagons, what are they? Octagons? You see, I guess they're hexagons. You see 1, 2, 3, 4, 1, 2, septagons. You see that the kube-proxy runs inside of Kubernetes in terms of like that it is a container. It runs in the container runtime. That you've installed on the system, and it brokers all of its communication. It handles all the communication to the API server from the kubelet, which is another daemon that basically just keeps Kubernetes running. But the daemon, the kubelet that's running, you have the container runtime, you have the kubelet that manages interactions with the container runtime, including the management and installation of the kube-proxy in order to communicate with the API. So the kubelet, the kube-proxy is the thing that directly communicates with the API. And that's why you have to install a kube-proxy on the control plane if you want to have an API extension. That's what these other certs are for that we're going to get to. Okay, so this makes sense to me now. So yeah, front proxy CA, that's what this is for. It's a front proxy. In other words, this is running a control plane proxy that's running specifically to talk to the API server on the control plane somewhere. It could be on the same server, it could be on a different machine, whatever. Front proxy client. There's a front proxy CA and a front proxy client. That's interesting. And I think we've covered everything here. API server, etcd client, we got that. We got the kubelet client. But the thing I keep asking the question though, is there a kubelet running over here? ps-ef grep kubelet. I think it is, and I just didn't see it because it's not it's an external daemon. Yeah, there we go. Yep. In fact, I'm pretty sure Kubernetes Up and Running is a book. Yeah, no. No, that book is nowhere near anything I would ever want to use. You can use it. I don't want anything to do with it. No, it's ancient. It's not even relevant anymore. But I would rather use the actual system and figure it out, unfortunately. Yeah, I wish it was relevant. It's not. It's really not relevant anymore. There's a few pieces of it that are still relevant. It's like Nana's tutorials on YouTube too. They're relevant, but they're like 5-6 years old. But they definitely have like I don't even think daemon set or stateful set is covered there. Yeah. So, and I would definitely never use a Raspberry Pi for my Kubernetes cluster. There's no way I would do that because it's ARM. There's no packages for ARM. If you're going to do it, you can pay less money for a Dell Optiplex server that's got faster IOPS than Raspberry Pi, and you'll still pay less money. You'll pay $100. Raspberry Pis are $200 if you can find one. So I'm not interested in that at all. So next steps. So we've determined then that the kubelet is there, but I want to check the health of the kubelet. systemctl systemctl status kubelet, I think, is a service. Yep. All right. So, in fact, I think kubelet is the only service. I do. Besides etcd, etcd is a etcd is a static pod. So no, there's no service for that either. In a stacked architecture instead of an external, we have a stacked etcd architecture configuration. So the only service, Kubernetes service, you will find on the system running is kubelet. That's super interesting to me, because I mean, so yeah, so if you go looking for these components, you would look for a service for kubelet, but the scheduler is a static pod, won't find that as a service because it's running inside a container that's being managed by kubelet on the control plane. But there's no kubelet even indicated here on the control plane nodes, which is frustrating as fuck for a beginner if you wanted to know where this stuff actually is. Okay, so yeah, I'm super happy I'm going through it this way, because this is how you figure out how something actually works. So that explains the kubelet client. Now, you can't have any communications with the API server without a kube-proxy. Period. You have to have a kube-proxy. But as I said before, the kube-proxy is, and I'll prove it, get or pod unable to determine. Oh, we have to sudo that. Let's see. So, oh wow, it's not running over here. Oh, right. Because the kube-proxy, we couldn't start up the kube-proxy. It's in that pending state because we don't have a CNI installed. So that's why the kube-proxy daemon set has failed to start. It has failed to start on this endpoint because there's no CNI. When there is one, that's where you'll find the kube-proxy. Yep. And then that's what enables. In fact, that would imply that a kube-proxy is fundamentally dependent on a CNI. I need to put that in my notes because that's a big deal. Hey, appears kube-proxy is a static pod. On a CNI. So that is a big deal. You found me. How you doing, Fuzzy? I move around all over the place. Are you talking about category? So yeah, I feel like we're making progress here. Where's our diagram? So we're almost done with this diagram. So we have API server client. Now we have. So this is a preferred PKI setup, and this is. Feeling better? Yeah, I'm feeling fine. I was a little bit frustrated last night because of this. I mean, the default is shit, and then we have to spend all our time redoing it. So, and then here's the default. So we actually have another set of things to look up. We have we have two more sets actually. So, but I have a really pretty diagram that shows the difference, and I am looking forward to getting that understood. All right, so once again, we've got API server on there. We've got API etcd client server on there. Sure, you can always ask silly stuff, as long as it's not going to get me banned. You're also on YouTube, so just know that. API server kubelet client, and then the front proxy CA, and the front proxy client. And then we have all the etcd stuff. So there's a bunch of top level stuff that's here. Yeah. I might have to amend this thing to have actual names in here. Yeah, let's just keep going here. So we have an API kubelet client. Who signed it though? I'm guessing probably the ca.cert that signed it. So let's go find out who signed that one. Where is it? Where is my command? There it is. Okay, so let's do API server kubelet client. So that API server kubelet client, I'm guessing this is the one that talks from the API server to the kubelet. I don't have a lot of hardware answers for you. So we can see that this is not a self-signed cert. It was signed by the CA, the Kubernetes CA the Kubernetes CA, and system masters kube API server. I wonder if this makes it into a TLS, an MTLS, a mutual TLS certificate. I don't know. I'm kind of curious to see. Yeah, so we can see right away it's not a CA. It's false. It can only do client authentication. It's the same thing as basically a web browser would do. So it's only there to talk to servers that answer, and the server in this case is the kubelet. So this is an API server to kubelet communicator. This is the cert that gets the API server, and then the API server says, "Hey kubelet, I want to talk to you," and it uses its client cert to connect to the kubelet server cert, which should also be here somewhere. Why does the kubelet not have a server cert? Is this the server and the client or the API? I don't see it. Let's see here. This is super interesting. I don't see the cert. Which of these certs is here for the kubelet to talk to the API server? It's got to be this one. All right, so that's actually in the docs. Let's go look at the docs. Yeah. Yeah. External CA mode. So checks expiration, yeah. Control manager, SC health, SC peer, server, scheduler conf. Oh yeah, where's the scheduler cert? There's no scheduler cert either. What the hell? There's supposed to be a scheduler cert. It even said so. Why didn't it create it? Is it going to create it automatically? Arrow attacks. I do not know. This is really weird. No, that's not it. No, the scheduler has to have a cert before we can even start up. This is inconsistent with what's been documented. God damn it. This is one of those times when we're left to guess. We're left to guess. We have no idea. I thought they had a list of them. Let's go see. So here's this page that lists them all, right? So we have the Kubernetes, which isn't -ca, it's just Kubernetes. That's a bug. CI certain key, etcd certain key for the etcd default. So these are the CAs. These are the top level CAs. And then we have the from proxy CA. So we have 3 CAs that sign the other certs, right? On top of the above CAs, it is necessary to get a public-private key pair for service account management. So that's the thing. We also have. So those are all the CAs. That's all well and good. And then here's all the certificates that are used under them. So the parent CA etcd is a kube etcd peer. Okay, so that's so that etcd can talk to things and other stuff. etcd health check client, API etcd client. We know this one. We know that one. And then we have kube API server, kube the client is just a client, and this talks. And this must be the kubelet one. This must be the one that goes on the kubelet to talk to the API server. That's the only thing I can think of. Yeah, that would make sense because this is the same kind. I don't know what that means. These are both clients though. So the API server is a server, host IP, advertise IP. But there's nothing here for the scheduler at all. There's nothing here for the scheduler. And it said right there, this is just so fucked up. It says right here, the client certificate config for the scheduler to talk to the API server. That's a client cert. There is no client cert listed in that group that is for the scheduler at all. So this is a fucking lie. Unless it generates it dynamically. I don't know. We'll go see. Certificate pass, etcd. etcd certificate should be placed in recommended path as used by KubeADM. Path should be specified using a given argument location. Kube API server, etcd, kube, say no. No, it doesn't. Client CA file, etcd CA file, cert argument. Key argument, etcd dash key file. etcd cert file. Add client CA file, TLS private key file. Kubelet client cert. Kubelet if you request client CA file from her proxy, request a proxy. etcd CA cube. Health check. SA key, no, the service account. There's no reference whatsoever to the scheduler. There's nothing. There's nothing for the scheduler. This is. That must mean that the scheduler is using the kubelet one. It's got to be. I'm sure it's just using the kubelet one. There we go. Here we go. Configure certificates for user accounts. You must manually configure these administrator account and service accounts. The default scheduler manually? Well, there you go. That's why it's got there. Configure certificates for user accounts. You must manually configure these administrator accounts and service accounts. So fucked up. Kubelet.conf. Default auth. System node. Controller manager.conf. Default controller manager. System kube controller manager. Schedule conf. Kube schedule. Okay, well, at least we can go look at it. Must match precisely the value of no name provided by the kubelet as a register with the API server for this is because this is I'm almost positive that the scheduler is using the kube client, the kube API, the API kubelet client. What do you bet me? What do you bet me that's what it's using? Yeah. I'm going to go find out. System kube scheduler, current context, blah, blah, blah. This is a manifest file for, I think it's a static pod, right? Is the schedule even running? I don't remember. Yeah. Yeah. Yep, static pod control 1. So we know that's a static pod. Uh-huh. Kube scheduler. edit pod cube, edit pod dash and cube system, cube scheduler. It's got, there we go. See, yep, source file, mirror. So that's a static pod. Okay, so the scheduler is a static pod, which means it's in the manifest. If we keep going back farther, actually that's what's here. That's what this is. We have the manifests. You want to see it? So everything in the manifest is a static pod. etcd, our QVAP that we added there, the kube scheduler, and it means they were configured by a YAML file. So kube scheduler, kube control plane, kube system, kube scheduler. Yeah. Authentication. So it uses scheduler.conf for that. So let's look for that. So scheduler.conf is going to have a key, client key data. I bet that this is I can't prove it, but I want to say that this can't, the scheduler, I mean, the scheduler must be, that's not using pod communication, or it depend on CNI. So it's got to be using API communication on the control plane. So that means it's from one static pod to another static pod using the API server as opposed to the internal CNI stuff. Because otherwise it wouldn't run. So I don't think that requires a CNI. I don't think that's, it's configured to, I mean, wait. But how is, if it's, how can it initiate communication with the API server without having the client key? Unless it's getting proxied. I think it's got to be the API server kubelet client. It's got to be that. It's got to be the kubelet client, because the API server is the server. The kubelet client is the client. So if you want to talk to the API server, you have to use the client key. So the thing I don't understand is on the kubelet, where are the certs? So if I go over to Mini 1, maybe those certs got installed in there someplace. I would expect to find all that stuff in Etsy Kubernetes. PKI. Okay, so what static pods are running over here, first of all? No static pods whatsoever. We have the kubelet.conf, which has got, you know, the stuff. It tells you what certs to use. varlib kubelet PKI kubelet client current.pem. Ooh. So this is not listed. Okay. This is not saved on the control plane, even though it is created. So this is, there we go. So you have a ca.cert. Yep. And I wonder if that, huh. Yeah, I don't know, man. It's got to be using, why does it have its own CA? All right, let's go in there and look at it. OpenSSL, X509, text dash in c.cert. Dash no out. Pipe that to foo.yaml. and then vi foo.yl. So okay, so this is the CA for Kubernetes. This is the basic CA for the whole cluster. This is not. This is just a copy of the CA that's in the top level. I don't understand how communication is being initiated from here, because there's no certs over here to do it at all. And maybe it's the tokens and stuff. Certificate authority data. This data might be the stuff we're looking for. If I could compare these certs to see whether they are varlib kubelet client cert. There it is right there. Varlib kubelet PKI. That's weird that it would be. So the kubelet has a completely different PKI infrastructure. Oh my god, there it is. Kubelet CRT. Yep, that's it. All right, well, I know where it lives. Kubelet current client is just a PEM file. Begin cert, insert private key. So that's the key and the cert. So that's the kubelet client. So wait, is that a server cert? All right, let's do our examination of that. Let's do an examination of kubelet cert mini 1 CA. It's like a self-signed local cert. Okay, so that's a CA. I'm guessing. No, it's not a CA. It's so weird. It's a self-signed cert that it's not a CA. Oh, it is a CA. Because the numbers are different. Aren't they? No, they're the same. It's a self-signed cert with no CA. Okay. Kubelet client current. That's actually a symlink. And that, okay, so this one is signed. This is the official cert that represents this node. Because look, it's been assigned to this node. It's been assigned to this node, and it was issued by the Kubernetes CA. So we need to capture this name because this is super important. This stuff is not stored in etc Kubernetes though. That just gets pushed out to the client. So, and it's not listed anywhere on the docs. So where's my diagram again? All right. So this CA is actually signing a bunch of other stuff. It's signing something that's like way down here. And we'll call it, I mean, it has a totally different location. I mean, these things are on the control plane, right? These things are on a node. And this key name is, what is this key name? This key name is kubelet client-current. Yep. Kubelet client-current. And that is, it's got a secret key identified with it. kubelet client dash current. Okay. I'm still not sure if this is used to, and it's a PEM file, which means the reason it's a PEM file is because it has a secret key in it also. Yeah. That PEM file has a secret key and both. .pem. And I'm going to delete this because it's going to have this little thing. It's going to kind of go inside of it because it's a PEM file. So this is, and this has, I mean, yeah, what was the CN on that? The CN is this. We'll just use this as a O equals system.nodes. I mean, it's some kind of groupish kind of thing. So that is kind of off on its own, and we are like separated out, right? So this is on its own node. So this is on a mini one node, and it does have an arrow, so it is issued by that same CA. I don't know what's going on over here, but so, and there was some other fun stuff on the nodes too. So, we should probably put colon var lib kubelet PKI. Right, so, and this stuff actually, probably put control plane over here. We'll just call them control. And these are all in slash etsy kubelet. Etsy kubelet PKI. So maybe we can move this around and stuff, but this is super important that we have this kind of stuff around to keep track of, because this is, yeah, all this stuff is on control, and then this is on the node. I'll clean this picture up later, but etsy kubelet PKI, and on a node we have varlib kubelet PKI. There's also an etsy kubelet PKI, which is confusing as fuck. Because, and there's also a kubelet CRT here, which, I mean, what the hell even is that thing? So this is kubelet.crt is a self-signed cert for some reason, and I don't even want to list it because it's confusing. I'm like, what the hell is it? What the hell is it? It's also dynamically created. I don't know what it is. I don't know what it is. But I'll put it here anyway. Yeah, let's put it here anyway. We'll call it so, yeah. I mean, what the hell is it? CN equals mini. So this is totally self-signed. Oh, no, it's not. It's not. Look, so the CN is this, and the CN is dash CA. So it's created as CA. But where the fuck is the CA? There is no CA. There's no mini 1 dash CA anywhere. Is it in here that I'm not seeing? Is it in the other PEM file? Where's the CA? This is not a CA. This is something that was signed by a CA. Well, where the fuck is the CA? It's not in the Kubernetes client. No, it's not. It's not in it. It's not here. It's not here. All right, so no, because the CN is this. This is a different CN. This is not it. This doesn't even have permission to do signing. See, it's not a CA, so that's not it. So where the fuck is this getting signed from? Where is it getting signed? Is that getting signed from Etsy kubelets? Kubernetes? PKI? I mean, is it this CA cert? How's it going? Is it this one? ca.cert. Nope, that's just a copy of the Kubernetes certificate without the key. So that's not it. I'm really confused. I have to go through the source code and look. I'm going to have to look at the source code. It's not documented anywhere. I'm going to put question marks here. And so this is kubelet.cert. And the CN is var lib kubelet. PKI. And we're doing a kubelet.cert. CN equals whatever the fuck this is. This is the CN. Actually, it does have a key, though. It does have a key. It has a key with that key file. I just don't know where it comes from. This is not signed by anything. I'm going to actually capture this just to show the confusion. So this has an issuer line. That doesn't make any sense at all to me. So it doesn't need to make sense. I just would rather have it make sense. Well, I don't know where that is. I have no idea where that thing lives. It's like out here in the ether somewhere. And I have no idea. And we still don't have the front end stuff here, but I don't even know if I want to do it. It's confusing. It's not even needed unless you do an API extension server. So there might be some certs in there we can actually delete. The three main CAs are the etcd CA, the Kubernetes CA, and the front end CA. The front proxy CA, sorry. So that's what we have. So if I'm gonna do my own PKI, I have to create a new root cert and then do all these others, which is of course a pain in the ass. Yeah. I think it's going to be it for me today. I'm going to go call it and go take a nap. This is I don't know how useful this has been for me. It's really solidified a lot of knowledge and also created a lot of questions. I'm going to go ahead and write this anyway because I know it's there. There's a front proxy dot key and a front proxy .ca. And then there's a front proxy.cert. So so that this is kind of its own beast. We'll make it, I guess, a different color. I mean, it's kind of weird. Nobody really cares about it, so I'll make it gray. And that is what we get. More questions than answers, of course. It's always the best way to go. I actually got a lot of answers about what it was deployed. So let's do this. Let's do we have the CRT cert on the client that's there. And we have the CA that's on the endpoint in etc manifest, which is the same one, so we don't have to deal with that. We have, we can go ahead and close that one. Okay, so we got the front proxy cert-ca in there. That is in there for proxy-ca. From proxy-ca-key. And I guess we'll put this down here. That's kind of neither here nor there. We have the roots. We have all this stuff in etcd, which we haven't even done yet. And we'll do that. So let's go ahead and put the let's just put that there is an etcd directory. I'm gonna put to do etcd/star. So we still have to cover all of that, so we can see how all of that stuff is related. And we're nowhere near having a nice tidy root CA and then having these be intermediate series. We're nowhere near that. I mean, in a perfect world, we would take this and we would make our own certs that have a top level root CA, and then that would give us these, and these would all be intermediate certs. So, no, I'm going to put here no root CA. And this is the crux of the problem when you're talking about this stuff, because good PKI, you're supposed to have a tree of trust and whatever, and Yeah, there's no root CA in this at all. And in fact, there's a bunch of self-signed shit that we don't even know where it comes from. So whether you're a hacker and you want to break into this stuff or you want to protect yourself from it, you need to know how to set up all these certs. And that is why I'm doing this. That's why I'm going into it so excruciating detail about how to do it. Yeah, and I think on that note, I think that's probably going to be a place to end with more questions. This Etch a Sketch. Yes. So yeah, that I mean that covers it for tonight. I'm not gonna lie, it's gonna be work to set up the certs. It might take me another week just to set up the certs on my own time. I can't play with the certs at work. But I am gonna tomorrow at work. The first thing I'm gonna do is I'm gonna go in and I'm gonna look at all my certificates and make sure that we have all of that. They can be able to explain it because I couldn't even get a damn thing installed from their docs. No, you can't. No, you can't. I mean, you can, but it's they expect you to pay for training or to pay somebody. And by the way, all of the Udemy stuff has nothing to do with on-prem Kubernetes. Nothing. All of that fantastic Udemy stuff that everybody raves about has no fucking clue about on-prem. All it does is help you pass the CKA. So if you want to actually get good, you've got to do the pain and suffering of setting up an on-prem or punt and buy OpenShift or whatever. So this stuff is important. And there's a lot of dependent skill sets and knowledge that are not mentioned in the CKA. And that includes full knowledge of how certificate PKI works, which, up until a couple of days ago, I could not have really confidently said that I had. I feel much, much stronger on my certificate knowledge, my PKI. I won't be able to say I've graduated on PKI until I've actually set up my own CA, my own root CA, and I've done all of this. And I do want to do that, but I kind of want to know what I'm getting into. And you obviously can't depend on the documentation for Kubernetes because it's bullshit. It gives you an outline, but it doesn't tell you anything about how to actually set up your own certs. If you want to do that, there's still the hard way, kind of explanation, which is really, really dated and uses the Cloudflare stuff. But that is something you can do to refer to that. But other than that, you're screwed because nobody talks about it. Nobody's talking about it except for here. So I'm super happy to have this community. And yeah, this is kind of a mess, actually. It's almost like they just kept throwing certs in. It's like, well, and I understand why they probably did that, because etcd at one point was a completely separate thing. So to say that Kubernetes should be managing and signing etcd would be totally wrong. And that would also prevent you from doing external etcd versus stacked, which is the one I'm using. Backup of the backups, yes. I really need to talk to my manager, though, about where we're headed and our upgrade cycle. And I do have a one-on-one with him on Tuesday, so I will put it off to that. I'm going to go back. I'll be doing some REST API development this morning. A little bit later in the morning, I'm going to take another nap here, do another sleep schedule split, and then we'll be back to it. But every time we do this, I learn a little bit more. This is absolutely critical knowledge, and our team does not have it. So I feel justified, spending time learning it. It is going to be a pain in the ass. Yep. Which is why, I gotta practice doing it before I break something that matters. So, but yeah, so I'm tired, but I'm not really as annoyed as I was last time. No, I think Annoyance comes from, first, not understanding things, and two, having information that misleads you. Or having information, having official documentation that you can only use, and having people say this is the only thing you can use on the certification exam, and then have them say you don't need to do. It's root CA is advanced Kubernetes. That's not included in the test, and then not documenting the actual way to do it at all is this isn't technically Kubernetes. I'm like, okay, fine. And all you did was listen. Yeah. People hate certificates. This will humble the most, and of course you get it wrong, you're screwed. So let's go rate somebody fun. And you were just eating lunch. I mean, the good news is that I actually understand it. So when I see a self-signed cert, or I see a cert down here that has a CA that's nowhere I can find, which is completely useless, by the way, without the CA. You can't use a certificate without the CA. It has to be present to be evaluated. That's why the ca.key file. That's why the CA file from Kubernetes is downloaded to the Etsy to the kubelets as well. So they were telling me about that last time. They're like, you cannot have a certificate without the CA that goes with the certificate. So if you're going to do this root thing, you got to make sure you have all the chain there, otherwise it won't work. And so when I see the reference to a CA and I can't find the CA, I'm like, where the hell does this thing live? So at least I know the questions to ask. That's what I'm saying. I know the questions to ask. And frankly, I know Go, so I can go dig into the code and find it. Good morning, computer nerd. I am just about to hang it up, but I think we made some progress here. Yeah. And, yeah. I can totally see how some people would just say, oh, just let Kubernetes deal with it, though. Because you don't have to do this. You can just say, I'm just going to use the default. And Kubernetes will work. As long as you upgrade your cluster within every year, you don't have to even look at certificates. It'll take care of all of it for you. So that is something to consider. The default is set up for Certs, yes. Yeah, this is the default, actually. The default is not set up for a root CA. It's set up to have multiple root CAs, 3 specifically. Actually 4. 1, 2, 3, 4. This random one down here that gets auto-generated, I don't even know what that is yet. So that's at least 4 root CAs that are used in the default Kubernetes configuration. And the recommendation from the security team industry for Kubernetes for Cloud Native is to use a proper, hierarchy and to use a single root CA and have intermediate certificates. If you do this, you have to inject them into the default system so that they will be used. And that's the takeaway from this. Your dissection, and then you can explain it in Training Boost. Yeah, I mean, I'm eventually going to write a book about this, like hopefully a collaborative book with LBG and everybody else that says, okay, here's the definitive guide, like they said, or whatever, the practical guide to on-prem Kubernetes. That's probably what it will be called, the practical guide to on-prem Kubernetes, because nobody is writing about on-prem Kubernetes. No one. There is nothing. If you do a search on the internet on books about on-prem Kubernetes, there's a bunch about cloud. The 6 best books for books.com. Let's see what that says. Not even the creators. No. In fact, the number one recommendation is still Kelsey Hightower's book, or ancient tutorial. If you really want to understand Kubernetes, do it Kubernetes the hard way. It's completely irrelevant. But people who are into on-prem are always recommending it. So whatever. 6 books on Kubernetes. Kubernetes is a container management book list. Yes. Why learn Kubernetes? Extensible, efficient, blah, 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 blah. Use clear, precise language. Best books on Kubernetes. The Kubernetes book helps you gain insight into inner workings of Kubernetes. Deploy and manage applications of Kubernetes. Nope. Nope. No on-prem. Nothing on-prem. Nothing on-prem. It covers Kubernetes deployments, talks about services. This is like ultra high level Kubernetes. This is a pod. This is a deployment. This is a service. I mean, I thought that was hard when I was getting started. Just understanding all of the different resource types. There's like 10 or 15 of them these days. And just that, I say this is like kindergarten Kubernetes right here. Best book for learning Kubernetes. Kubernetes Up and Running by Joe Beda, Kelsey, and Brendan. This is an ancient book. Kelsey's, these are famous people. Joe invented Kubernetes. Kelsey's the big name on campus when it comes to giving presentations. Orchestration, how these, and Brendan helped build it with Joe, I think. Joe retired. Joe, when VMware got bought by Broadcom, Joe retired. He's like, I'm out of here. So the guy who invented Kubernetes isn't doing Kubernetes anymore. The contents of this book are concise. So as far as I know, I might have that wrong. Each chapter leads to the next. You won't feel the slightest need to skip forward. But it's so fucking out of date. It's completely useless. A solid understanding of how Kubernetes worked in 2016. Kubernetes in action. I think the person who wrote this book is actually in our chat a lot. I haven't read it, but I'm not interested in reading it. Talks about the first steps of Docker Kubernetes replication, deploying pods. No, volumes and disk management. Oh, good. They delved into persistent volume claims. Thank God. Usually that's considered advanced. Oh, it covers stateful sets. That means it's relatively new. Okay. Securing cluster nodes from the network. Understanding Kubernetes internals. Covering automatic scales of pod clusters, advanced scheduling. Best practices for developing apps, talks about extending Kubernetes. Probably with CRDs and controllers. Probably not with API servers and from proxy. I'm guessing, which are all things that they have no clue of. The people who wrote this probably don't even know what the shit that is. And this was written by we have at least 2 Kubernetes book authors in our community who have said so, who have claimed to have literally written a book about Kubernetes. So I got to be careful because, but this is why I don't write books. They're completely fucking irrelevant after a year. So if I cloud book on cloud developers, mastering Kubernetes, mastering. Oh, really? Mastering? Mm-hmm. All right. Let's see what that means. It goes beyond simple learning the fundamentals and its deployment. The book takes you into the journey of concepts. Does it help us set up an on-prem Kubernetes cluster from scratch with load balancing? Probably not. So master the fundamentals of Kubernetes, build a stateful application, use tools like kubectl and Helm. No. Oh, master Kubernetes networking with load balancing options like Ingress. Ingress is not a load balancing option. No, it's not. It is part of the load balancing option, but it's not. High availability clusters. Oh, okay. That might be good. That might be good. Include tools like Prometheus, Grafana, Jagger. Okay, so Jaeger, it's telling us actually. I mean, this is the most advanced of all the books so far. There's no doubt. That's the most advanced. Look at this. This book is updated to the latest tools in Kubernetes 1.18. I rest my case. This is why you'll never see a book from me unless it is a dynamic ebook that's maintained by the community. Because reading a book on 1.18 Kubernetes is almost worse than not reading any books on Kubernetes. But it's for masters who did Kubernetes back in 2017. It's also the only book available. Don't write books, man. Yeah, Books are bad. Tech books are really bad. People who brag about writing tech books all the time, I just laugh at them. I'm just like shaking my head. Okay. All right. You obviously don't buy into the idea that books are a bad idea. You just wanted to make a quick buck and write something that's immediately out of date, and probably had your ego stroked by Pact Publishing to do it. I don't do it. It's not a sufficient. I mean, unless you're doing a really actively maintained knowledge-based book, it makes no sense to do this. If the official documents on Kubernetes.io can't be kept the fuck up to date, how the hell are you going to write a book about it? Why don't you take all that energy and maintain the official docs and do contributions like that, instead of like selling out to sell a book to somebody that's going to get out of date in 1 year? If you really give a shit about the community, why don't you spend all of that time and energy, I don't know, maybe working as a consultant, doing the job instead of writing about how to do the job, actually doing the job, even if you suck like me, like making that money, and then spending all your free time instead of writing some book that you can, brandish about like you're some authority. Then actually, if you are such a fucking awesome authority, why don't you contribute that authority to the actual project and fix the fucking docs on Kubernetes.io? End of rant. That's why you will never see. I mean, I as I've said before, I want to help the project by writing documentation that's accurate, that covers the on-prem stuff and all of a sudden they might tell me, and then they're going to throw me to the wolves, and they're going to say, I'm sorry, you can't write about load balancing because it's technically outside of the scope of Kubernetes and we don't need it in a Kubernetes docs. I'm like, fine, then I'll write my book, and I'll do it with a community of knowledge experts and SMEs who do it every day, not who spend like a sabbatical writing a book about it, and by the time the sabbatical's over, all the shit they've written is out of date. Whew. Okay, so up-to-date knowledge, what is that? And that's what Maluba, that's exactly my point. The reason that every time I get started on a book and I like, no, I'd rather make my time organizing notes and keeping my notes and updated in a Zettelkasten, and then taking that to the next level, which is like a polished, dynamic knowledge base that is always better than a book. It's also usually free, which is why people don't do it, because they're not going to get, and they don't get to brag about it. They can't say, author of the following 3 books. If you're going to introduce a technical writer for having written 5 books, I just laugh at them and go, okay, obviously they think books are a thing. And people who run around as if books make them authorities, I just laugh at them. I'm like, okay, I think it's cool that you wrote a book. So what? It doesn't make you an authority just because you wrote a book on it. All it means is that you believe in the nature of books. And if you actually think books as a technical resource are a good idea in 2023, you have problems in the head. All right, I'm done. 642-page book is divided into the following chapters. I know that was too far. I'm sorry, that was too far. Talks about understanding Kubernetes architecture, guided you to create Kubernetes cluster, talks about high availability and reliability, covers security, securing Kubernetes, talks about Kubernetes resources and practice, stateful applications. Cool. And this is why I will never be allowed to speak to professionals in the Kubernetes world, because I question things that are like their core deep beliefs. They're very religious about it. And Kelsey Hightower is a fucking god in the industry, because why? He's done a lot of presentations, and he wrote some ancient tutorial that was relevant like 9 or 10 years ago. And now he's unquestionable because he's like a celebrity in the world. It's like, you can't, I won't do it. And it makes me very unpopular with those people. They feel like I'm attacking them. I'm not attacking them. I'm attacking their idea. Look, Kelsey was on the right. He was definitely on the right path by writing this very involved tutorial that he then let drop and didn't maintain for the following 13 years. And, but he's a big enough name that nobody gives a shit. He's so big, he doesn't give a shit about maintaining that knowledge at all. If he did, he would spend time maintaining the stuff that he's written already. Am I wrong? Probably. I mean, these people who feign interest in the community and like really all they really want to do is be influencers and ultimately get money and like speaking gigs at KubeCon and all this other stuff. They don't actually want to help. They may be well intentioned, but the fact of the matter is, if they actually wanted to help, they would spend more time, writing up-to-date documentation and streaming about how to do this stuff and helping people that are struggling like me and others, instead of like giving all this fucking lip service on the conference circuit. All right, so I'm done. Best book for serious learners, Kubernetes patterns. Okay, that's a cool one. Let's see about this one. Kubernetes patterns, reusable elements for designing cloud-native applications. Reusable Kubernetes patterns for container deployment orchestration. Each pattern includes a description of the pattern, problem on a proposed solution of Kubernetes. The book is well structured, foundational patterns. So this is like how to do things, but not really specifically. The cookbook is actually probably very specific. Helps you solve concrete problems around Kubernetes. Authors have compiled 60 hands-on recipes for automating deployment. Ooh, cool. Easy to look up solution, helps you find quick details. Creating a cluster, managing non-cloud native, securing apps. Yeah, it's all the same stuff. Nothing on-prem. So far, there's only been one book that even talks about on-prem, and it was made in 2018. And it's the only one that even has HA in the list of stuff it includes. More ways to learn Kubernetes. Udemy, you can go over here and learn the CK thing, which gets rated really high by everybody. Yeah, it helps them pass the test, but CKAD is crazy easy compared to CKA, like true CKA. Udemy, getting started with Google Kubernetes Engine. No, it's not. 70 resources. Yeah, I'm just gonna say it. If you're doing Kubernetes on-prem and you don't have a real good reason to do it, you're doing it wrong. The end. If you're doing Kubernetes on-prem and you have enough money to do it on-prem and to use A100s and stuff like that, and you don't buy OpenShift, you're probably doing it wrong. But the niche case of people who don't have money and have to do stuff on-prem because they don't have the money to do the cloud either, those people are the people that are getting left out. And that's the people I want to help. Who can benefit from Kubernetes. Most of those people are probably going to throw Kubernetes out and use Nomad or something simpler. OpenShift is expensive. It sure is. I know, but as I said, if you're renting, at $10,000 a pop to buy one, like a V100, if you're doing machine learning Kubernetes or something like that, if you have that kind of like crazy ass disposable income, like our company does, then using OpenShift is probably the way to go. Or using the cloud, subscribing to the cloud. I don't know. I don't even know how much money they're going to save by. Well, I take that back. They physically cannot do the machine learning models they want to do in the cloud because they do not have big enough GPU power. Bottom line, you cannot put a job on an A100 or V100 GPU in Google, GCP, any place in there, in Azure or Amazon. They do not have big enough GPU power to do the machine learning crunching that my company wants to do. So there is no other option than to do it. If they're going to do it that way, they've used PBS for most of it because it's mostly batch stuff. But if they even wanted to add it to Kubernetes, it has to be on-prem because they can't even get access to that level of GPU power from the cloud providers. And this is where NVIDIA is probably going to waltz in and just take over the machine learning cloud market. Watch, it's going to happen. Somehow, NVIDIA is going to figure out how to put all of that serious, all those CUDA cores, those big ass GPUs, and they're going to stick it. If they haven't already done it, they're going to make a cloud. They're going to make a cloud option, or they're going to partner with Google or somebody, and they're going to own the machine learning market completely. With ARM at that. No, they got denied with ARM. Yeah, they weren't able to buy ARM. They got shut down for that. So, but that's going to happen. It's going to happen because I can guarantee you that if NVIDIA started making a cloud offering, or more importantly, if they started partnering with GCP to provide V100 and A100 for an extra premium rate, that was reasonable and was less than what we're renting A100s and V100s for right now, that they would get all of our business. And I'm talking billions of dollars of business if they would do that. That's all they have to do. That's all they have to do, and then all of that work can be done in the cloud, and they wouldn't have to fight around with on-prem. Apply for NVIDIA. They need to get some NVIDIA stock. Hell yeah! If you have money to buy stock and you're not owning NVIDIA stock, you're a fool right now. The stock that's going to fucking destroy everything else is NVIDIA for a million reasons. Seriously, the one thing that enterprises can't, and this is where all the big money is. This is why I don't understand why it hasn't already happened. If NVIDIA is listening, or anybody who's this, I'm going to predict it. I'm going to raise my prophetic hand, and I'm going to say what I just said. NVIDIA is going to partner probably with an existing cloud provider because they don't have maybe they have the, dude, if they make a machine learning cloud that is as good as GCP in terms of like interactions and stuff, and it has Vertex AI and all that other stuff, which I don't think they can because Google's got a monopoly on Vertex AI. You can't get Vertex AI unless you have GCP, which is what every machine learning person wants, apparently. And if Google partners with NVIDIA to put big ass GPUs available for premium rates or for competitive rates, they will own the machine learning market. They will completely own it. And that will be pretty much all of IT within 5-10 years. Most IT is moving to everything for machine learning. They're not even doing traditional coding anymore. They're doing some of it, but so many applications are moving to just machine learning. Very practical enterprise level applications are becoming just big old machine learning models. They're not even doing algorithmic programming anymore. And that's going to be the trend. That's going to be the future. The future is more and more stuff's going to be implemented as machine learning models. And the more of that, whoever owns the market for machine learning hosting and for crunching, petabyte models and stuff like that, they're going to own the entire fucking market. And Google is the best suited to do that. Amazon doesn't have a prayer because Google owns the machine learning thing. Google is, PyTorch and is and then TensorFlow and all that stuff. Google has been at the forefront of the whole machine learning thing in terms of cloud. So if they partner with NVIDIA, if GCP partners with NVIDIA, you watch. The other cloud providers will like roll over and die. Amazon will continue to support things like Netflix and stuff like that. But if Google actually pulls this off, they will own Kubernetes, which they already do. They already own Go, which, they don't own it, but they own Go, they own Kubernetes. If they also own the machine learning market, it's over. It's over. And Google won't even have to do a single thing in terms of like search engine to make money after that, because the partnership with NVIDIA will totally destroy all the competition. I wish I was over there. I could help them influence those marketing decisions, because I have a customer from right now. If I swear to God, if NVIDIA partnered with GCP, I could go to certain directors in the company that I'm at right now, and I would say, you see all this work that we're renting these really crazy ass expensive GPUs for? You don't have to do that anymore. You can do it all in the cloud, and plus you can cut your expenses for HR and all the people that are supporting on-prem. And you can move all that stuff into the cloud, and you'll save lots and lots of money, and that's what I would do. That's what I would do. But somebody needs to go over to NVIDIA and tell them to do that. They don't care though. They're so big. They don't care about anything. Stop making graphic cards because NVIDIA is a pain in the ass to work with. Yeah. That's what I've heard. They're so full of themselves. They just do not care about anybody. They really don't care. They care about money. They care about selling to end user customers. And they look at how much one of these things is. Price of NVIDIA V100. Dennis had these the other day. Dennis had one. He actually has one, and he was showing it off. I think it's an V100. No, that's not the one. Is it a V100? I might have the wrong number. No, there it is. Display price $8,900. $8,900 to buy this this GPU. If you can get one. $8,900 for one GPU. It's like, that's insane, man. The idea that you could buy a GPU for $8,900. What is the V100? It's coming out in 2 days. Oh God. Yeah, that one's like even crazier, isn't it? The A100s are like 3,000. They're no 4 by NVIDIA Tesla A100, $45,000, $4,600. Hey, look, you can get yourself just for $4,600. People laugh. I mean, I paid 30 grand for my rack over there, everything in it though, over time, and I still have the debt for it. But this is crazy. This is just crazy. NVIDIA. Yeah, I mean, even with inflation and everything, you know, it's just like, it's so fucking crazy. Where's the, it's like all there. I hate the navigation stuff they put on the websites now. It's like, screws it all up. It's not even going to have the price you watch. How much memory does it need? Right up to 20 times higher performance than NVIDIA Volta. NVLink, NVSwitch. Yeah, a training workload like Bert can be solved at scale and under a minute. Shit. Oh. But can it run Minecraft? I don't know, man. Resident terabyte of unified memory per. It's just so amazing. This scale of technology. I mean, in the 50s, we were like, you know, using our fingers to get tape to work, and now we have $8,000 GPUs that. It's crazy. The pace of technology innovation is just insane. It's exponential, they say, you know. It's crazy. It's really cool. I mean, that's the place to go. That's why nobody can keep up, right? Yeah, there's no price on that though, of course. Yeah. I'm pretty sure the A100 is about 3,000 right now. What? Fanless NVIDIA A100 for 11,000? Shit. An A100 is $11,000. Oh my gosh. That's like so expensive. What? What is that? A Supermicro GPU server. Oh, it's a server. It's a 4 by Tesla. 4 by Tesla A100s. So 4 Tesla A100s for the rock bottom price of $46,000. Did you find it? Yeah. Probably time for me to stop streaming now. Jetson AG. No stock available. I wonder why not. Supplier unconfirmed. ARM. 8 ARM cores. Huh. Yeah. Out of stock. Yeah. Yeah, they're all out of stock. Yep. Yeah. And PNY, yeah, A100, 800 80 gigabyte A100. Yeah, $45,000. Anyway, this is the kind of stuff that if you buy it, it would be great if you could rent it. You can't. I don't think you can rent. Can I use NVIDIA A100 in the cloud? I don't think they even offer it. Maybe I'm wrong. What? A100s are available in Google Cloud's Compute Engine. They've already done it. Oh my God, they did it. When did this come out? They did it. On Google Collab. Shit, they did it. Why am I stuck? I am stuck. Is the internet still up? Oh, that's not fun. Damn it. Why does it not work? Can I use NVIDIA A100 in cloud? I bet you it's only Google, right? Here we go. We're getting stuck again. God damn it. You think they are? Yeah. A100 GPU. And this would make a lot of reason. This would make sense because we're pretty heavily, hot and heavily moving to GCP. That's not a business secret. Maybe I'm in the cloud. ND1 A100. Cloud's ability to make GPU usage more affordable and accessible. The problem is it's still so expensive. Yeah. Lambda Labs. I've been starting to hear about Lambda Labs a lot lately. Yeah, I've started to hear about them more lately. They're like kind of an upstart, right? Hourly cost of 800 GPU for on-demand cloud compute. Yeah. Yeah, this is interesting. This is super interesting. The reason this is interesting to me is because this means that things like on-prem Kubernetes will go away. There's still going to be a need for it, but it's not going to be, it's going to be for operational APIs and things like that integrate like we're doing with our batch stuff. It's not going to be, it's not going to be for machine learning. So there are teams though in our company that do not have the money to even do this. And they want to like skunkworks something and experiment and try different things. And so that's why we exist. They want to try things internally out. And if they want to do something big, they use our batch processing, which is like second to none in the world, actually. But you know, a lot of the official application jobs that have budget and stuff, they're all going to GCP for this kind of thing. It makes me wonder why, if LambdaWorks would be a thing to set up for cloud GPUs. Lambda Labs. Yeah, iterate faster, scale differently. One NVIDIA A100 40 gigabytes VRAM per GPU. 30 vCPUs. Shit. $1 an hour? Oh my god. 8 Tesla and V100s for $4 an hour? Shit. Okay, I have a question. How do you get your terabyte or petabyte models up to the system though? This has been an ongoing pain point. This has been an ongoing pain point for machine learning. How do you get models like raw data for a model to even process on here? You would have to wait. I mean, the transfer rates, look, we have terabytes, petabytes models. Yeah, but not like a 900 terabyte model. Dude, we have big ass data models. I mean, really, really big data sets. I don't know. I still feel like that's not covered until we get the next generation internet. I don't think that data storage is going to be possible. There are storage providers online, but it's weird because they don't even let you get your raw storage. You just have to leave their stuff in there all the time. You can't even get to it. It's because they're kind of being proprietary with it. But they are the place you can put your raw data initially, and then you gotta. So I mean, even if you can, I mean, this isn't really affordable, but then you've got to buy the storage for that. Yeah, but look, I'm not talking about the NSA. I'm talking about a company that needs to transfer stuff. What are they going to do? Ship them a drive? No. I wonder if they could actually do that, though. Does anybody know if they have a product that does that? That would be a very realistic workflow. If they I mean, the only problem with that is security, chain of custody. Because God, some of these data models, if that amount of data was compromised, it would cost millions, multi-millions in damages to the company to release some of that data if ever it got in anybody else's hands. Especially since some of the data is I can't talk about it, but a lot of the data is not completely anonymous, we'll say. I can't talk about it, but some of the data is not completely anonymous. So, sensitive materials, yeah, we'll say that. Yeah, I mean, even just the data set itself is worth millions of dollars. Millions of dollars. I wish I could talk about it, but just having the data, just owning that data from literally millions of data points, relevant data points, just owning that data is worth millions of dollars all by itself. This is why companies like this are not forthcoming. Oh, hey, this is why people like this are not forthcoming in their in their sharing of this information with sociologists and stuff like that, because it's worth so much money. It's actually really bad for the world. It is. It's really bad for the world because there's so much amazing data that's being gathered all the time, and it's not being given to the scientists. It's being given to the people who want to leverage it to make money off you. What? Oh, you like that? Nice. Yeah, it's been nice. It's fun watching you. I like your terminal. The data transfer you would have to trust whoever you're sending it to. Yeah, that's the hardest part of it all. How would you send the data over there to do that? I mean, Los Alamos trusts them, Carnegie Mellon and stuff. I mean, this is a real business problem that I'm not at that level, but I'm interested in it. I'm interested in the business problem of this. Lambda has covered the pricing. They've covered the pricing model, but nobody has covered how to get the model data to these systems and store it economically. If you put it, I mean, I'm not even kidding. There's petabytes of data that in some of these models, and so yeah, I want to say a petabyte. I think I've heard that. There's definitely multiple terabytes of data. Some of the models are so big. How do you get a model that's that big into the cloud? Right? Safely. How do you get it into the cloud safely? That is a huge problem. It's a very basic problem, but it's very real. I mean, there's people have been talking about splitting up machine learning jobs and stuff. And I mean, that buys you some time, but that's, and there's your on-prem use case. Jalopy, that's what I'm saying. So as long as that's an issue, as long as storage is an issue, it doesn't matter how cheap the GPUs are. We have this exact problem right now. And that's why I'm asking the question. We have this problem. We have the problem both ways. We have some teams will do all of their model crunching in GCP, and then they're like, they want to use the results of that, the models that come out of that and stuff. They want to use that at work, and so they want to put all that stuff, and they need to transfer all that data back over to on-prem. And then you have people that have massive on-prem jobs that want to take that stuff and put it up in the cloud. We have this problem. It's a real big problem. The data transfer to the cloud is I think probably the biggest single pain point in all of enterprise IT right now in the machine learning space is data transfer. Remove hard drive, insert hard drive. I actually think that might be a possibility. I'm not kidding. I think for some of these models that take years to get the data for it, that updating their data set by sending over a new drive is the most effective way. I really think that's probably true. Keep it on the same disk and physically transfer the drive, yeah. AWS snowmobiles. I'm going to ask around. I don't know if I could even talk about that if I knew, because that would probably be proprietary. I tell you what, the company that figures that out will win. They will win because they'll have figured out the biggest enterprise IT problem in the machine learning space. I mean, where to run your stuff is one of the problems, but it's not even the biggest. It's like how to get your models to the right place safely. I'm just playing with the cheap-ass homelab, yeah. My data is all going to be generated over here and run over here, and it's going to heat my neighborhood at some point. But, I mean, I don't even know how to do machine learning yet. I mean, I know the concepts, but I'm looking forward to doing that. I'm looking forward to throwing my cluster at some machine learning jobs, specifically distributed machine learning modeling across multiple clusters and storage classes with relatively small PVC. That is something I really want to explore. Some of us are going to hate me, I know. Yeah. Alrighty. I mean, I appreciate the raid, everybody. I'm actually going to go raid somebody else. I am going to get a few winks of shut-eye before I have to go back to work myself. Learn how this shit works. You can explain it to me. Good luck finding what... Oh, AWS snowmobiles. Very hard to find. I don't know. So there's my kubeIDM init finally. But I do have to set up my... I'll show it off one more time. I am going to have to... Where's my Excalibur? Where's my Excalibur go? Please don't go away. Oh, I have to save it. I'm so scared. I did all that work and I don't want to lose it. Where is it? If I would close the window right now, I'd lose it. I need to export. Wait. Export as... And I'll overwrite my other one. Homelab etcd TLS cert organization save. Yes, replace it. If you want a link to... If you want a link to my default diagram, here you go. If you want to go take a look at it. It's not very good yet, but you can go. It's hard to click on. You have to copy and paste that. But this is so. This is just to summarize in case you jump to the end of the YouTube video. This is my understanding of the default certificate setup for Kubernetes, and in contrast to what I would like to set up, a more hierarchical root CA. Which I now know is going to require, not require, but probably benefit from a change to my host naming conventions. And right now, so that's probably going to be my next task. I don't know if I'll even do that on stream. I'm going to actually fully qualify all of these guys and see how that goes. Yeah, so... You know, I'm probably going to do the... Whoopsie. I'm probably going to do... Until I get DNS or something, I'm going to do, like, the fully qualified... in a host file, you can actually put 2 entries, right? I think you can put 2 files in there. Yeah. So... There's a man page I didn't see host. Did you know that? So... Oh, look. It actually did a man page. I tried to open it. That was dumb. There we go. The man page describes, okay, so IP, canonical host name, and aliases. I think the canonical hostname is the one that has to have the fully qualified domain. And I don't do that regularly at home because it's a pain. But since Kubernetes is using it, at least in this situation, I'm probably going to need to fully qualify that. And that means I'm going to need to pick a home domain besides example.com probably. I'm probably going to do lab.rwx.gg. So I need to change all of that. Yeah, see this? See, it has the fully qualified is often used for the FQDN of the machine. And then the rest. In fact, I'm kind of glad that I ran into this because I don't know. I'm glad that I ran into this because it's making me clean up my etc host file before I do a distribution of this. So that will be the next thing that I do related to my lab. That has nothing to do with work though, so I won't be ever streaming that during work hours. But that is something I need to do before I proceed with my PKI certificate setup, because I want the certs to be correct, and they're going to be building them off of the host names. So that's good to know. That is really all I have tonight. So I'll put the flux back on. Turn the fluxy on. So thank you for joining me for tonight, this morning. Yeah, the sun is going to be up any second here. Let's go ahead and I'm going to leave this thing here. Who do we have to raid? B7's not streaming right now, so who do we got? Anybody have any guide the raid suggestions? All right, bye YouTube, by the way.